Okay, welcome back, everybody. To kick us off for the second morning session here, we're going to have a speech from David Schultz from IceCube talking about the IceCube CredMon.
Okay. Right. Clicker. Very good. In the theme of MMA, I will talk about IceCube, but also I'm not going to talk about IceCube. So I'm more on the computing side, and for quite a while, IceCube's been working with Condor, and in this case with Pelican as well. And so this talk is primarily we were trying to solve the problem of how do we get Pelican authenticated data transfers working, and it turned out we decided to just write our own CredMon for reasons. But anyway, if you don't know what IceCube is, this is the lab at the South Pole. Its general mission is to look for neutrinos, and we found a few. So generally, it's located at the South Pole, but we do all the computing in the north. If you like deployment pictures, here's a picture of a new sensor going into the ice over the winter. So there's over 5,000 of these sensors buried in the ice. They can see neutrinos through Cherenkov radiation in the ice. It's actually a very good place to see these things. But then the other part of it is, once you see these things, what do you do? We have a real-time data pipeline that takes data from the south to the north. We also have bulk processing in the north. We use the OS pool quite heavily. But for this actual talk, I'm not going to care too much about the science. I'm going to care more about how does the data actually get processed. So we've started leveraging the Pelican platform, obviously because we're based in Madison, Condor's based in Madison, Pelican's based in Madison, so that's clearly the path to take. We also have a token server that can issue WLCG compliant tokens that Pelican can understand. We have a nice namespace in OSDF. It's very simple, IceCube and Webpack, which is just where our servers are located. And everything in that namespace is behind tokens because our physicists believe all of our data should be private for reasons. Then, because we're part of the OSDF, the Pelican director there can manage all the redirection to get everything from whenever the Pelican client issues a request to our actual origin servers. That works fairly straightforward. The real question is, what about this part in the middle? What does Condor actually do, and how does this actually work? So first, we tried the default OAuth2 parts of Condor, and you could kind of sort of make that work for some limited cases, but it didn't really issue the tokens that we wanted in the way that we wanted. At first, every time you submitted a job, if that token didn't exist, it pointed you out to the browser and said, hey, please log in this browser session. And our users really weren't going to like that at all. The other one is if you were using Dagman or if you're using the Python bindings or other things, it didn't play well with this interaction because sometimes you just wouldn't get the prompt to do the OAuth interaction in the browser. So obviously we said, the solution isn't working. We can just write our own solution. Or actually, I think Brian told us, hey, why don't you just write your own? And so we did. So we developed this. I decided to pick Rust because this is going to be a fairly critical part of the security in here. And I said, I don't want any weird vulnerabilities to come up. But primarily the thing is we don't really want to inconvenience the user at all. So if we can, no user interaction at all. Also, we're assuming since we have an AP, like they have logged into our AP somehow, because that is the way that we process things is they must log into our submit machine. So that's probably good enough on the authentication. Then one of the things that I had noticed about the way the HTCondor built-in one was doing things is it was putting the client ID and secret in every metadata file for every single token that you generated, which was not ideal. And so I said, since we're writing our own, let's fix that part. So as I mentioned, this is in Rust, primarily for performance and safety. Obviously, Rust is known very well for memory safety, and so that's the whole class of vulnerabilities that we didn't need to worry about. It's also very performant. That it's minimal overhead, and since token generation happens a lot, we wanted it to be very fast. It's also very easy to deploy. It's a single static binary, or actually technically in this case 2 binaries, but it doesn't matter if we upgrade the AP to a new OS, it will continue working. And then just to reiterate, since all of our users are going via SSH and they have connected via LDAP, they've already logged in with their password. We're trusting that their local session is already good enough. So for job submission, there's actually an SUID based binary. It fetches the user ID from whatever it was called from, and then it can run as root and do all of the accessing of like, here's the client secret, here's where I write the tokens to. The other part is when you need to refresh tokens, that runs just like any other Condor daemon. It's actually launched by Condor. So that works as you'd expect a CredMon to work. So what does this actually look for a user? So first, they run Condor submit. This Condor submit actually triggers one of the processes to make token creation happen. This first obviously checks, does the token exist? Because if it exists, then I don't need to generate it in the first place. If it does not exist, then it will go try to fetch the token from the token issuer. All of our researchers are told, hey, you need to include some scopes with this submission. So then it will ask the issuer, hey, are these scopes valid? If they're not, then it will fail and tell the user like, hey, you don't actually have permission to read or write to this place. But if it succeeds, then the user just doesn't really see anything. The submission just continues. And then once finally the job's in the queue and we have all the tokens, the job will start. Condor will send the access token to the worker with the job, and it will periodically update the access token as it gets refreshed. And finally, you obviously do a transfer. So the Pelican client built into Condor can use this access token, use the OSDF, access our data from our origin, and everything is good, hopefully. Since I figured this was a more technical talk, I would include some config. So we are using this magic command, sec credential store, that allows you to run any program you want whenever it asks for this token. And then in the CredMon part of it, you just specify that I am running this CredMon. One interesting note is that we kind of had to trick Condor into thinking that this was running the vault secrets because that was the only way to do it without popping out to a URL for the built-in auth configuration. So this is vault, but not vault. And then obviously you set what is your issuer address, what is your client ID, where is your client secret, And all of our binaries can read all the Condor configuration, so they can see all of these. And then there's a minor hack to tell the store binary, like, which provider is this in the config that we're actually using. This was just a weird workaround to make all of this work. And if the Condor team has a better idea to solve this, that would be great. One of the interesting things is that you can only have a fairly large minimum on the token time. We discovered this the hard way by setting too small of a minimum first and then wondering why some transfers were failing. It turns out that the set credential refresh is set on the EP side, and if you're running on the OS pool, you do not control that. So this value had to be larger than that value. The other one was just the time between refreshes, and you just have to set that to something fairly low, but in this case, it refreshes it every 60 seconds, or it looks to check whether it needs a refresh every 60 seconds. So just comparison between the built-in flow and what we've done with our CredMon. Obviously, the previous one required the external web browser, and we took that part away. It now works well for Dagmans and for other things where maybe there isn't even a user there, but you can still issue tokens. We also took the secrets out of the metadata files and said they are only stored in the Condor config. And then the operational failure rate obviously went down quite a lot because our users didn't have to complain about all of these other things. And other than hardware issues, it has just worked, which has been really nice. Yeah, so I said some of this already, but the general user feedback has been very high. They've liked that previously we've been using X509 certificates, and they had to manage those. And at this point, they don't do anything with that. They just say, I would like to access these directories. Here are the file transfers I want to do, and it works, which is great. So things that we're still looking at. Obviously, while this was designed for IceCube, it could be used by others. I would say that the only thing that's might be a minor issue is because we knew that we were talking to our token issuer. There might be a couple specific things there, but it generally speaks what you'd expect for OAuth token issuers. And then we've been talking with the Condor team about a new prepared job state to remove the SUID requirement. A number of the hacks that I've put into the submit process to support users actually making this work. And that would just clean up this workflow a little bit. So that's all I have.
Okay, questions? Ooh, quite a few. I didn't see who was first, but Cannon's going back there first.
So what's the package called? CredMon something? Condor CredMon something?
Yeah, it's just called Condor CredMon right now, I guess.
Oh, you don't have an optional package to put it's included in the standard CredMon RPM?
No,
it has
not yet. I know Brian's been asking about borrowing some of this for his new thing.
Oh, so it's just kind of stuff that you add on. It's not part of the Condor package yet.
Yeah.
Okay. So yeah, give a nice generic name. Don't call it like Rust or something like that. Yeah.
Go to one of the Todds next. I'll let Cannon choose.
Great talk. Could you clarify a bit, like, how do you authenticate to the WLCG token server and the set credential, piece? When you run Condor submit, it runs your set credential producer, and how does that prove your identity to your token server?
So part of it is that we've assumed that if someone has logged in to the AP, like they've sort of proven that they are that person at that point.
Okay,
So we trust that they are that person, and then our client basically issues a token on their behalf. So it just grabs their username and says, this user wants to create a token with these scopes. Is that allowed? Yes. Okay, I'll have the token now.
so you aren't going to a token server, you have a secret key there and it just
It does
create.
go out and ask a specific token server because we can use our token server for things other than Condor.
Right, so again, how does the set credential producer authenticate to the token server?
Yeah, it uses an OAuth flow. Specifically, it uses what's called token exchange in OAuth.
Okay. And because you have access to the client secret and the set credential producer, your token server trusts your flow. Okay.
Yeah, so we basically told the token server, this client is allowed to impersonate users.
Got it. And the set credential producer runs as set UID, so you were able to read the client. Understood. Okay, thanks.
So this sounds a lot like a local issuer, which seems like it would have been a little bit cleaner as a setup. And I was wondering why you chose not to do that.
Yeah. So the local issuer would have worked, but then it only would have worked with Condor, and we wanted it to be able to work outside of Condor as well.
First, talk to me about preparing. And what about remote submit? Do you have a solution for that?
Currently, we do not have any remote submits. I think it's possible, but we haven't looked at that yet.
Right now, since you use the UID of whatever user's logged in, is it have to be a one-to-one mapping between the username that the person whoever's logged in as, and what your token server is expecting to have asked for
Yes.
their ID?
So at least in this case, they are exactly a one-to-one mapping because we obviously control our issuer. So
Is there any plans to add any kind of ways to do like mapping, or I don't know if you have a different set of identities on one end from the other?
we don't, because we don't have that problem,
Yeah.
but maybe Brian does.
Okay.
Is this the first component that's written in Rust that you guys run in production?
It's not the first, but it's near the first.
Okay.
We're gradually transitioning a bunch of our more performant tasks over to Rust. So
Okay. Thank you, David.